And both halves of your face.
All right. So I've started this collaborate session. So we're going through, this was the homework, first five questions, or 5 questions. Part A is to figure out if we're going to use a one sample t-test or a z-test. Now, so our collaborate's just in a regular room, and I'm trying to figure out how to make a poll. I can't remember how to do that.
Blackboard?
Yep. For sure. So I guess I'm going to have to ask. Blackboard, collaborate, poll. I hope I don't have to like share a screen or something like that. Create poll. Oh, okay. So let's share. Poll. All right, so t-test or z-test. So t-test. All right, so what we will do is got a collaborate session open. You can see my end of it. I've got a poll. So we will start with question 1. So what you can do is kind of go through, look at question 1 through 5. I'll do the poll one at a time. And what we'll do is I'll give you about 5 minutes to get your answers. Maybe you can talk to the person next to you, see what they think. This way we can do it a little bit asynchronous. Does it show you the responses on your screen? No, it doesn't. So we'll start with like question 1. 7 no responses. 6 no responses. 5. Question 1. I only have the first question up there. I have to do it like one at a time. Four more responses. Waiting on it. Those of you that came in, we're answering question 1A first. Is this is one sample t-test or a z-test? And for those graduate students that have been trying to register for the 6301 course, you probably can't register for it. So what I'm just going to do is email and Dr. Hammerman and Dr. Dixon with a list of the graduate students in this course. So all of them should be able to register. And for those undergraduates who think they might go to graduate school, you can always get provisional enrollment into our graduate program so you can take the grad stats. Those that have done so have not had to take the grad stats course up at Texas Tech. 3 semesters. Okay. All right. Well, for hold on. One of those is me. I didn't vote. So 1 short. Don't make me call you out if you have not voted on question 1. All right, so how do we tell? How do we tell if it's t-test or a z-test?
Population and deviation.
Yep, so we look at the standard deviation. Is it the population standard deviation or is it the sample standard deviation? All right, so what do we have here? Population. So is it z-test or t-test? Z-test, right? It's population. So show the response. You should see it on your screen. All right, 13 said a z-test. I did not cast my vote. But we also have one of them. All right. Question 2. Let's see if I can edit this. Share screen. Hold. Multiple choice. Update. There we go. Question 2. T-test or z-test?
It's not letting me click my answer. It just says no response.
Anyone else?
Yeah.
End the poll. Yeah, let's end the poll. Let's try it again. Oh, that one's better. Maybe it was because I edited it. say you t-test or z-test. This is question 2. Sample. Uh-oh. Lost. All right. All in. A vote. T-test was 14, Z-test was 2. Do we have a population standard deviation or the sample standard deviation? We've got a sample. So the mean and standard deviation of this sample is 20 and 2. So if we have a sample, we're going to run our t-test. All right? Clear it? I can click on it. All right, so number 3. Average grade for course A was 71. You found a student's grade sheet on the floor. Their average was a 79. Is there statistical evidence that this student was in course A? One sample t-test or a z-test? Oh, no. See, cast my vote. I think Will is watching us. He's having difficulty getting into Blackboard. So I had a question. How often do you find yourself getting kicked out of the Blackboard Collaborate? Because I've seen it when I've run these things. I've seen students that some students have a hard time staying connected. Will's having issues. That's one reason I don't like using Collaborate. All right, here's our results. Question 3. Do we have our sample or our population standard deviation? We've got our population. We've got sigma. Sigmas are always our population. That tells us we're going to be doing a z-test. All right. And in this case, you have the average grade for course A is 71. That represents our population. Our sample was that one paper that we found on the floor. All right. So our standard error was sigma over the square root of 1. All right. So clear it. This is question 4. Last fall, the final exam took an average of 114 minutes to complete. This year, the final exam, n equals 18, was completed in an average of 95 minutes. S squared equals 40. Was the average time to completion for this year's exam less than the time to completion for last year's exam? One sample t-test or the z-test? Yeah, Maddie said she hasn't had an issue, but she's seen others that had issues. That's my daughter did the computer programming class, HTML class over the summer, and it was all Collaborate, and there was 1 or 2 days where she kept getting kicked out. rebooted her computer and fixed it. Again, I don't know why it did that. All right, show the results. All right, here, do we have our population or our sample standard deviation? We have our sample, S squared. So S squared, S, that's always our sample. Sigma, sigma squared, that's always our population. So if we have our sample standard deviation, we're going to do our t-test. And let's do our last one. Average height of American men is 178.2. You sampled the height of a tour group of 12 men that were visiting Walt Disney World. The average height is 188.2. S equals 5.1. Are these men Americans? It's not open now.
Dude, that's lovely.
What?
Just because they're tall doesn't mean they have to be from another country. They're playing. There's so many people in America. You can easily pick 12 of them that are that tall. I'm sorry.
I mean, you're right. I mean, it's still.
It's not because the obvious answer is we can't know whether or not they're American. We can't know
Based on their height. Based on their height. So we can. So, in the biological sense, you're right. Our question is, are they American? We can't know just from their height. But if we extend it, then we do our statistical test, and we say we reject the hypothesis that they are American, but maybe they are. What type of error did we just commit?
Say that again.
So we reject the claim. Maybe they're too tall for average height of Americans, right? We reject the hypothesis, but they are actually Americans. What type of error did we just commit? Type 2 or type 1? It was a type 1. You reject, so that's why we set it at 5% to make it hard. But if we didn't, it kind of goes the next step. Why did we make the type 1 error? Does this represent a random sample of men in America? No. No. If it is a basketball team, as you say, which you're right, yeah, entirely possible. Yeah. Yep. Then we don't have a random sampling. We make the assumption that this is. But actually, I do believe when I pull these numbers, 178.2 centimeters is the average height of America at the time when and 188.2 centimeters is the average height for another nationality. So sometimes I don't make the numbers up. Sometimes I actually do look at them.
That's where they
But question 4, those were all made up. Question 4 was all made up. Yeah. I think this was made up. Although, if you remember the example of the cell phone, average length of a cell phone, that was real. I looked those numbers up. All right, so yeah, question 5. T-test or Z-test? Did I vote? I didn't vote yet. There we go. All right. So it comes down to what do we have? Sample or standard deviation, or sample or population. We have an S, that is our sample. Sample always goes to a t-test. All right. So now we have the answers for all of the A's. That will now allow you to do this. Do question B without making a mistake. Question A was make your choice. Question B was perform the test. Now you know which test to run, so you shouldn't make any mistake in choosing it. And then, performing the test, question C was using R to obtain the p-value of the test. We're already going to be using R to get your p-value. Okay? I showed you how to use the table, but again, we weren't really doing things by hand. So use R, use your p-norm function, use your pt function, get the area under the curve, get the p-value. So here this group is actually from the Netherlands. Look at that. Average height of men is 184.8. Not terribly tall. Yeah, maybe it was a basketball team. Or the Netherlands could be the long distance speed skating team. Right? Long
Yeah,
distance.
you could.
I don't know if that's tall person. Yeah, okay.
Go. All right, so
Anything about
I think what we'll do is we'll get out of collaborates now that we did our poll. So, all right. So we might do those a little bit more. So we're back. This is where we left off. Sign test. So we violate assumption, we're non-normal. We want to go over how to do this sign test. So our sign test tests that median is equal to some value, all right? And know that we're not comparing the median. So how are we going to do this? I'm going to transition to the board. I'm going to kind of give you a data set to show you how we're actually doing it. Is there a piece of chalk over there? Or do I need to bring one? Big piece or tiny?
This size.
Let's get a bigger one.
Actually, there's this one.
Some people have a difficulty throwing chalk away. I don't. Just trash it. Oh, I should have warned our people watching. Motion sickness. Or caught up. What's that? That big motion. My daughter did car seat. We kept her preoccupied with saying child stuff. It helped. All right. So what we're gonna do is I'm just gonna make up a data set. Okay? So what we're gonna do is actually let's make it up. Type in R. Down at the console. Let's do which distribution? Binomial. Okay, do R binomial. Parentheses. How many days? That's 12. Say 12 sounds good. 12 comma size equals size equals 2 out of 15. Comma we'll do a probability of 0.3. All right, you're gonna read off those numbers.
5, 4, 5, 2, 7, 8, 4, 5, 3, 4, 5,
5. So there's our data set. All right, that's our data set. We run it. Let's say we're non-normal, so we can't do a t-test. And let's say our t-test was interested in testing if our mean was equal to, I don't know, 6. Our mean was equal to 6. That's what we were testing. not normal, so we really can't do a t-test. So instead we're going to do a sign test. And our sign test is going to test if our median is equal to 6. Okay, that's what we're going to test. And it's just arbitrary. And our alternate then is we'll say that our median is not equal to 6. So this will be our sign test. What we'll do with this sign test is compare each of our values and assign it as either a plus or a minus. A plus means that we're above our median, a minus means that we are below the median, or below this hypothesized value. And a 0 means that it's not there. So a 5 is below, those are all below, that's above. Those two are below. All right, so I've got my pluses and minuses. And then I'm going to count up what I have. All right, so I only have 2 pluses. And how many minuses do I have? 10 minuses. All right. Now, if our median is equal to 6, then we should have an equal number of pluses and minuses. We should have an equal number of pluses and minuses, which means the probability of getting a plus should be 0.5. The probability of getting a minus should be 10. That should be 0.5, right? All right. If we equal a median, then it just kind of drops out. We match our median. We're still concerned with that plus or minus. So what we're going to do is look at this. Based on this, we'll make our hypothesis that the probability of getting a positive is 1/2, and our alternate is that our probability of getting a plus is not equal to 1/2. Right? So what we've done is taken a continuous type of variable here, discrete variable numbers, and convert it to a plus minus, a yes, no, a true, false. What kind of distribution does that follow? It's a binomial distribution. So if we look at a binomial curve, we can have 0 all the way up to 12 pluses. Number of pluses, with 6 being right in the middle, right? Because we had 12 items, right? And our curve is going to look something like this. Not as smooth, but something similar. We saw 2 pluses, right? So in order to calculate our probability of getting data as extreme or more extreme under this case, if this is true, then what we're going to do is calculate this area under the curve there. And it's also, we need the opposite way. So at that. Now, with our binomial, when we do this, this is 1/2 of our p-value. This would be the other 1/2 of our p-value. The curve's not perfect. It's close. But what we can do is take what this sign test is doing, median equals to 6, do this conversion, and then we're doing something what's called the binomial test, where we are testing, is the probability of success actually equal to 1/2? Now, how do we do that? Well, this area under the curve is a probability of getting 0 plus the probability of getting 1 plus the probability of getting a 2. Using our binomial, can we do that? Can we calculate that probability? Yeah, how do we do it? In R, it's the D binomial, right? So it's a D binomial of 0 successes out of 12 if our probability of success is 1/2. We would do 1 is D binomial of 1, D binomial of 2, and we can add them up. All right? If our probability of success is equal to 1/2, then this distribution is also symmetric. So we can do this area and multiply it by 2 in order to get the two-tailed test that tests this part. All right. So that is what our sign test is actually doing. All right, it's testing. We're testing against the median, and it accomplishes that by converting all of our values to pluses and minuses and running this test. All right. So I explained conceptually what's happening, and I mentioned our p-value. Now what we can do is we can use a p-binomial. P-binomial exists as well. We've used p-norm, we've used pt. Now there's also a p-binomial, but it's kind of tricky because this lower dot tail equals t and lower dot tail equals f specifies whether or not we include that value, that 2 value, 2 or the 10. So what I like to use is what's called the binomial test, the binomial test. And this tests the likelihood of getting our number of positives out of our total sample sizes under the assumption that our probability of success is 0.5, which is exactly what our sign test is doing. So a binomial test, you can run it on your own, but if you have continuous discrete data where you need to convert it and to do this median test, the sign test, this is what it's doing. All right? So what's the general code for the test? All right? So this is the general code for our sign test. All right? And it's a block of code. But you'll see what we'll do is give it our vector. Say, okay, this is the vector of data that we're interested in running. All right? This is going to be our hypothesized value. This is going to be what we're going to test against. And then this part does everything for us. So the only thing that we have to change are these 2 lines. So let's open up RStudio and let's do a quick example. Let's do a quick example where we know we violate normality. All right, so we're going to introduce our sign test. We're going to generate an example data set. All right. You can set your own seed. I'll do today's date for 1. And what we will do is I will create a data set that is skewed. So I'll call it DAT1. I'm going to round it to, I guess, 1 decimal place. So I'm going to do 100 data points. I'm going to do it for r chi-squared. So chi-squared distribution with degrees of freedom of 3. I know that's going to be skewed. I am going to load my car data, my car library real quick. Get it loaded. And then I'm going to run this. And actually, as part of this, I'm going to do my QQ plot on DAT1 just to confirm that I am not normal. So this is mine. If you use the same seed, you'll get the exact same figure. If you choose a different seed, that's fine as well. All right. But you should get something that looks kind of like this. So we're non-normal. All right. So let's see. I don't even know what my summary statistics are. All right, so our mean is 3, our median is 2.2. So we'll do I guess 2.6. That's what we'll do. So in our practice, this dat 01, let's test, is the median equal to 2.6? And we're going to use the time test for this. So our null hypothesis for the sign test is that the median of our vector is equal to 2.6. Our alternate is that the median is not equal to 2.6. All right, so not equal to. Now we can do this by hand if we want. We could do this by hand, but we won't. So what I'm going to do is I have my slide open. And what we're going to do is do our sign test using the code that was on that slide. So what I'm going to have to do first, bummer, can't select it. So I'm going to create my vector. All right. So this way, once we get it run, there's only 2 lines that we have to change. All right. So this is going to be our data vector, and you may need to record it as data $ variable if your data is in the data frame. And then we have height val, which is our hypothesized value. All right. So I leave everything the same. These 2 lines are the lines that we're going to do, that we're going to use. And then what we're going to do is we're going to create a vector of positives and a vector of negatives. So we're going to convert each of our individual data points, the numbers, into a positive or a negative value. So my positive value is going to be all of those positive values where our vector is greater than our hypothesized val. All right? So this is the vector greater than height val. And then what I'm going to do is take the sum, because that's going to add up how many of those pluses we actually have in our data set. Because if you remember from when I worked through it, we needed to know how many positives and how many negatives we had. Right? Actually, we only needed 1, but our second one is really aimed at figuring out the total. How many are out of number. So this code, vector greater than height val, is going to go 1 by 1, and it's going to key it as either a 1 or a 0. 1, it's true. 0, it's false. So then when we take the sum, we know how many positives we have. I'm going to do the same thing for the negatives value, but this time it's going to be vector is less than our height val. And you'll note that I don't do anything for the equal to the median. Those values just drop out. All right, we assume that they don't exist. Because if our median is actually equal to that hypothesized value, then we're only concerned with we should have the same number of pluses as minuses. And then what we're going to do is figure out our total number, which is the sum of our negative and our positive values. So this ends up being our out of number to do our binomial test. And then I'm going to do this. I'm going to figure out which of these is my smallest value. All right. So I'm going to take the minimum of my negative and positive values, and that is the smallest. Now, on the board, I showed how to how to do this using the positives, it works with the negatives. All right. So if we had 10 positive values, right, the smallest would be 2 negatives, and we end up coming up with the same probabilities because we've got a 50-50 chance, just how it works out. And the reason we do the smallest is so that this last code, binomial.test, works. And it works no matter if we have a bunch of positives or a bunch of negatives. So we're going to do our binomial test where we test how likely it is to get this smallest number of values out of our total number of values under the assumption that our probability of success is 0.5. All right, and we're doing a two-sided test here. We're going to do a two-sided test. So now that I have that code set up, all that I have to do is run. Now it gives me the exact binomial test. But and this is kind of what we did, but we did the binomial test because we're doing a sign test. And the sign test itself is converting our numbers to positives and negatives. So the number that we're interested in is this p-value. That is the only one that we're interested in. So our write-up, our median is equal to 2.6. We did a sign test where the probability, our p-value, is less than 0.09. All right? We don't have a test statistic associated with this. We don't have degrees of freedom associated with this. We actually did a sign test. We did an exact probability test. Because we could. Because it's a binomial distribution. So that is the code for the sign test. There's only 2 things that you change. Questions? Yes, no? Let me open something up. All right. Here is a function for the sign test. You don't like it? I know. I've already saved this. I know I did. No, I guess not. See, that's gonna allow me to save. All right, so you can look at this and see what it looks like. What I'm going to do is post this on Blackboard. Because what I've done is made a function for the sign test. And I think this, and we'll see how the actual code works in our function. Oh, it's already on. Should be available. Oh, on it. Display activity. There. All right, here it is. Let me move over. In our Blackboard, we have functions. It has been empty. I actually have several functions that we will show. So there's the R. All right. I think it's the same. Yep, it is. I don't see any changes. So this is what's posted. You open it, you can open it in a text, in Notepad, in WordPad, or whatever. But what you would do is copy this. All right. I'm going to copy that. I'm going to go into my RMD file. And I'm going to create a function section. I'm going to paste it. And now what we're going to do, I don't know why that, I'm going to run it. All right. And I'm going to demonstrate that we get the exact same p-value here. So I ran it. Go down here. All right, so here's the output for our sign test function. All right, so sign test is going to take our vector, dat01, our median, that our hypothesized median, is 2.6, and our alternative is two-sided, which is the same thing that we did. All right, and what I've done with this function is created it so the output actually tells you what we did. It tells you what test we ran, a sign test. It gives you the actual median of the vector, 2.2. It gives you the hypothesized median, 2.6, and it gives you the p-value. All right, it's exactly the same thing that we did, but it gives you a little bit better output and a little bit easier way to run it, because I know this can be kind of tricky. You can look at it and say, I have no idea what it's actually doing. Well, we're doing a sign test. That's ultimately what we're doing. We just have to go about it in a little bit different way than a lot of our other tests. So let's look at the function. Here's our function. You're going to see everything that we did. So we have our vector. So that's the first thing we do. I made the vector. I saved it as an object. And then what I did was calculate the median. Do we actually need it? No, we don't need the median of the vector, but I think it looks a little bit nicer in the output to say, here's the actual median of our vector. And we're comparing this median to our hypothesized value of the vector. And then you can see that this has everything that we did. The positives, the negatives, the total. And then we've got a few things here that basically, on the slide, on our presentation, I said, if we're going to do less or greater, we may have to adjust what our smallest value is going to refer to. Is it going to be the negatives or is it going to be the positives? This takes care of it for you. It figures out if we're doing a two-tailed test, then we're going to take the minimum of the negative and positives. If we're going to do a one-tailed test, then we're always going to take our positive value. And it's going to work. Our binomial test, exactly what we want. But in this case, I don't want to see that we're running a binomial test. The only thing that matters for us is our p-value because we're running a sign test. And then the rest deals with the output. So we run this function, we run a sign test, and it gives us the nice output, just like our output for a t-test. Just like our output for Shapiro-Wilk test. Tells us the test, tells us what data we're working with, observed, hypothesized mean, and our p-value. Questions? This will make it real easy. So you have the function. You just have to get it into your RMD file in the function section, run the function section, and then signed out test appears, and you can use it. All right, so all right, so pond 1, all right, with all of our ponds, so this was pond 1 using the actual just copy, paste, updating. But if you ran the sign test on this, will get the same p-value. So what we're going to do with the pond, we're going to assume we were testing against the mean. We'll test against the same values for the median. So for pond 1, does our median equal 24.5? Run the sign test. For pond 2, is the median equal to 25.15? Pond 3, is the median smaller than 25.05? And pond 4, is the median greater than 23.75? All right. And this can work because, again, if we were normally distributed, and we are with these, then our mean and our medians should be equal, or be pretty close. So go ahead, use your sign test, test against these values, and obtain your p-value and do a quick write-up for our sign test. pond 4 yet? Is it an error? Yep. Yep. But I'm gonna guess that wasn't checked out. So we'll update the code. Right. I'm gonna update that R sign test. I'll tell you what we can do. All right. So I've updated the function. So I've updated the signTest.r that's in Blackboard. I replaced it. Forgot. I don't have like the NA checking ability. So I quickly added it here. So in our function, if we use, instead of vector and then x, if we do na.omit of x, and that's going to strip out all of the NAs before it does the sign test. And I think that's what we really want to do. All right. I'll warn you though that if you do like bootstrapping on this, and you try to use the sign.test, it's not quite going to work, because if you have some missing data, that's kind of something that you have to account for. It probably isn't going to affect us. Normally isn't going to affect you. I guess it comes down to more of the theoretical side of things. When should we bootstrap with missing data? But I updated this in my function up here, and I ran it. And then when you run this pond 4, it's going to work as planned. Yep, but if you ran it and you thought, oh yeah, I've got missing data in there, yeah, that's how we can kind of fix it. And I just went ahead and fixed it here in the function. So hopefully you can see how it's actually pretty easy to run the sign.test. All right. The sign test is converting to plus and minuses, and then it runs a binomial test on it. So our null hypothesis for the sign test is that our median is equal to some hypothesized value. Our alternate is that it's not, or it's less, or that it's greater than that, some value. So for pond 1, this is my p-value. Is our median equal to 24.5? No, it's not. All right, so what was your write-up? Yep. Yep, median is not equal to 24.5, the sign test, and our p-value. Right? Pond 2, is our median equal to 25.15? Yeah. Yep. So, same type of deal, with our write-up. Right? Our conclusion. So our median is equal, or appears to be equal, to 25.15. We ran the sign test, and our p-value is less than 0.08. Pond 3. Ran this just to make sure it works. What's our conclusion? Yeah, our median is not less than 25.05. And it worked. I actually did the less than, and it worked as it should. All right? Which is what we want it to. It's how we hope it should work. last one had some missing data in it. We added the NA.omit to try to handle that and catch it. So a write-up. It's a write-up. Yep, it is greater. Right? So we ran our sign test, p-value. Pretty easy. Well, hopefully, it's pretty easy. Right? Questions? Right, so we did all these things. Were any of the conclusions from the sign test different from the one sample t-test? So this, we'd have to go back and look at our t-test. Binomial test, our QQ plots, t-test. Here they are. So yeah, number 4, we said mean is greater, so that agrees. Question 3, mean is not less than 25.05. That agrees. Upon 2, we said the mean is equal to 25.05. Does that agree? Yep. And then we said the mean is not equal to 24. Does that agree? Yeah. So in most cases, if we meet the assumptions and we did our non-parametric test instead of a t-test, we would get the same conclusions. The exception being something like this, where our t-test gives us a p-value that's close to 0.05. And I'm not saying above 0.05, I'm saying we'll get a value of, let's say, 0.04 or maybe 0.03. All right? In that case, our t-test may say that we reject our null hypothesis, but the non-parametric test would say that we don't reject it. And the question is, why would that be the case? Well, it's that case because the non-parametric tests have lower power. We have less ability to actually detect those differences when they really do exist. So a t-test is going to be more likely to find a difference than a sign test. But if the sign test finds a difference in our mean, then a t-test will always find a difference as long as our assumptions are true. All right? So if we find a significant difference with the sign test, then we're always going to get a significant difference with our t-test if our assumptions are met. If we find a significant difference with our t-test, we might not find a difference with our non-parametric test just because we have less power. All right? Questions? All right, we're going to stop here for the day. We do have the homework assignment that you can work on. Again, I know that third question, part C, was all about using R to calculate the p-value. You're already going to be doing that. All right, you're going to answer the questions, run your t-test or your z-test, use R to get your p-value, and then do a short write-up. All right. I'm going to make an assignment so you can scan and upload this. You can do it in R as an R markdown, or you can do it by hand and write it by hand, and then just take a picture and upload it. That can also work. All right. If you have questions, please email me. And those of you that came late, and I don't even know how many are still watching, but remember, if you're a grad student and you're trying to sign up for the grad stats course, I don't think you can until we finish this class. Don't ask me why. I have no idea. I have no idea. But, I mean, to show you how crazy it is, I advise a student who took botany and zoology but doesn't have the principles, biological principles 1 and 2, which like, one of those classes has to be taken, right? Yeah, right? So I advise them, and of course you can see that they have the transfer credit for an equivalent, like first year course. But I said, I don't know how you were even able to register. But then I gave them the option, and they thought botany and zoology easy. They really like botany. So I said, if you find botany being easy, and I said, then if you want to take principles 1 and 2, go be my guest. I said it'll be a cakewalk for you. All right. Yeah, don't forget registration's open. Graduate students are less important unless you're taking a 5,000 level class. But even then, grad classes normally don't get registered until the core classes start. All right. Email if you have questions.
Really?